Hello to all of my lovely subscribers and audience. In this video, we're going to talk about some further concepts in Java language of programming. If you like the concepts, please subscribe my channel. Thank you. Our topics in this video are object-oriented programming, structured programming, OOP, and different way of organizing a program. OOP is traits, encapsulation, private or public, class, member, polymorphism, inheritance, the Java development kit, Java for small programs, NetBeans, or Eclipse. Okay, let's start. Object-oriented programming. At the center of Java is object-oriented programming, or OOP. The object-oriented methodology is inseparable from Java, and all Java programs are to at least some extent object-oriented. Because of OOP's importance to Java, it is useful to understand in a general way OOP's basic principles and before you write even a simple Java program. OOP is a powerful way to approach the job of programming. Programming methodologies have changed dramatically since the invention of the computer, primarily to accommodate the increasing complexity of programs. For example, when computers were first invented, programming was done by toggling in the binary machine instructions using the computer's front panel. As long as programs were just a few hundred instructions long, this approach worked. As programs grew, assembly language was invented so that a programmer could deal with larger, increasingly complex programs using symbolic representations of the machine instructions. As programs continued to grow, high-level languages were introduced that gave the programmer more tools with which to handle complexity. The first widespread language was, of course, Fortran. Although Fortran was a very impressive first step, it was hardly a language that encouraged clear, easy-to-understand programs. The 1960s, talk about structured programming. The 1960s gave birth to structured programming. This is the method encouraged by languages such as C and Pascal. The use of structured languages made it possible to write moderately complex programs fairly easily. Structured languages are characterized by their support for standalone subroutines, local variables, rich control constructs, and their lack of reliance upon the goto. Although structured languages are a powerful tool, even they reach their limit when a project becomes too large. Consider this, at each milestone in the development of programming, techniques and tools were created to allow the programmer to deal with increasingly greater complexity. Each step of the way, the new approach took the best elements of the previous methods and moved forward. Prior to the invention of OOP, or object-oriented programming, many projects were nearing or exceeding the point where the structured approach no longer works. Object-oriented methods were created to help programmers break through these barriers. Let's see how OOP build a different way of organizing a program. Object-oriented programming took the best ideas of structured programming and combined them with several new concepts. The result was a different way of organizing a program. In the most general sense, a program can be organized in one of two ways: around its code, what is happening, or around its data, what is being affected. Using only structured programming techniques, programs are typically organized around code. This approach can be thought of as code acting on data. Object-oriented programs work the other way around. They are organized around data, with the key principle being data controlling access to code. In an object-oriented language, you define the data and the routines that are permitted to act on that data. Thus, a data type defines precisely what sort of operations can be applied to that data. To support the principles of object-oriented programming, all OOP languages, including Java, have three traits in common. What are the traits? Encapsulation, polymorphism, and inheritance. Let's see what is each one. Encapsulation. Encapsulation is a programming mechanism that binds together code and the data it manipulates and that keeps both safe from outside interference and misuse. In an object-oriented language, code and data can be bound together in such a way that a self-contained black box is created. Within the box are all necessary data and code. When code and data are linked together in this fashion, an object is created. In other words, an object is the device that supports encapsulation. What about private, public? Within an object, code, data, or both may be private to that object or public. Private code or data is known to and accessible by only another part of the object. That is, private code or data cannot be accessed by a piece of the program that exists outside the object. When code or data is public, other parts of your program can access it even though it is defined within an object. Typically, the public parts of an object are used to provide a controlled interface to the private elements of the object. Let's see what is class. Java's basic unit of encapsulation is the class. Although the class will be examined in great detail later in our process, the following brief discussion will be helpful now. A class defines the form of an object. It specifies both the data and the code that will operate on the data. Java uses a class specification to construct objects. Objects are instances of a class. Thus, a class is essentially a set of plans that specify how to build an object. Let's see what is a member. And the code and data that constitute a class are called members of the class. Specifically, the data defined by the class are referred to as member variables or instance variables. The code that operates on that data is referred to as member methods or just methods. Method is Java's term for a subroutine. If you are familiar with C or C++, it may help to know that what a Java programmer calls a method, a C or C++ programmer calls a function. Let's talk about polymorphism. Polymorphism, from Greek meaning many forms, is the quality that allows one interface to access a general class of actions. The specific action is determined by the exact nature of the situation. A simple example of polymorphism is found in the steering wheel of an automobile. The steering wheel, for example, the interface is the same no matter what type of actual steering mechanism is used. That is, the steering wheel works the same whether your car has manual steering, power steering, or rack and pinion steering. Therefore, once you know how to operate the steering wheel, you can drive any type of car. The same principle can also apply to programming. For example, consider a stack, which is a first in, last out list. You might have a program that requires three different types of stacks. One stack is used for integer values, one for floating point values, and one for characters. In this case, the algorithm that implements each stack is the same, even though the data being stored differs. In a non-object oriented language, you would be required to create three different sets of stack routines with each set using different names. However, because of polymorphism, in Java you can create one general set of stack routines that works for all three specific situations. This way, once you know how to use one stack, you can use them all. More generally, the concept of polymorphism is often expressed by the phrase one interface, multiple methods. This means that it is possible to design a generic interface to a group of related activities. Polymorphism helps reduce complexity by allowing the same interface to be used to specify a general class of action. It is the compiler's job to select the specific action, for example method, as it applies to each situation. You, the programmer, don't need to do this selection manually. You need only remember and utilize the general interface. Let's talk about inheritance. Inheritance is the process by which one object can acquire the properties of another object. This is important because it supports the concept of hierarchical classification. If you think about it, most knowledge is made manageable by hierarchical, for example, top-down. Classification. For example, red delicious apple is part of the classification apple, which in turn is part of the fruit class, which is under the larger class food. That is, the food class possesses certain qualities, edible, nutritious, and etc. Which also logically apply to its subclass fruits. In addition to these qualities, the fruit class has specific characteristics, for example, juicy, sweet, and etc. That distinguish it from other food. The apple class defines those qualities specific to an apple. Grows on trees and not tropical and something like that. A red delicious apple would in turn inherit all the qualities of all preceding classes and would define only those qualities that make it unique. Without the use of hierarchies, each object would have to explicitly define all of its characteristics. Using inheritance, an object need only define those qualities that make it unique within its class. It can inherit its general attributes from its parent. Thus, it is the inheritance mechanism that makes it possible for one object to be a specific instance of a more general case. Okay, now we are very near to write some simple programs. In order to write, we need to install some Java Development Kit or JDK. We are dependent on the 11th version of JDK, but you can use the higher versions too. The last version of JDK that is released until now is JDK 15. I will put in a description the link that you can download the JDK to use it. And I want to say that the JDK supplies two primary programs. The first is Javac, which is the Java compiler. The second is Java, which is the standard Java interpreter and is also referred to as the application launcher. Okay, if you have a question about Java for small programs, for example, if you want to ask that you state that object-oriented programming is an effective way to manage large programs. However, it seems that it might add a substantial overhead to relatively small ones. Since you say that all Java programs are to some extent object-oriented, does this impose a penalty for smaller programs? I want to answer this question by saying that no. As you will see, for small programs, Java's object-oriented features are nearly transparent. Although it is true that Java follows a strict object model, you have wide latitude as to the degree to which you employ it. For smaller programs, their object-orientedness is barely perceptible. As your programs grow, you will integrate more object-oriented features effortlessly. Okay. Notice that you can use NetBeans or Eclipse to write Java, but we are dependent on JDK because of its availability and similarity. And our way of coding are according to JDK and does not work to NetBeans and Eclipse, so notice the point. I think this video is enough and the section is over. Have a nice time.